So we'll see some structure of ionic compounds, ionic solids, some of their properties and some of their uses. Ionic compounds mostly are naturally occurring, and you'll find them in the earth crust and the rocks in the mountains. Plenty of kind of stones and rocks making basically this solid earth, and human makes full use of it. All ionic compounds are basically solids, and some are high melting solids. The reason is because in ionic compounds every particle, atom that has turned to ion, particle, is either a positive ion or a negative ion, so they are locked into strong electrostatic force of attraction. And these positive and negative ions are arranged in fine layers. And these layers not only go in 2D fashion, rather in 3D fashion they grow. When they grow in 3D fashion, then layered arrangement in 3D style makes it a crystalline ionic solid. They have a crystalline, peculiar crystalline shape, like rock salt, NaCl, although not very strong ionic compound, because it is only 1 plus and 1 minus electrostatic force of attraction, but way too strong as compared to many other, because 801 it melts. So different ionic compounds have their own crystalline shape. Over rock salt, the famous rock salt, NaCl has cubical shape crystals. Magnesium oxide also has cubical shape crystals, and 3D layers arranged in a cubical fashion that each positive ion is not attracted by one negative ion, you may be thinking, by 6 negative ions, and each negative positive ion by 6 negative, each negative by 6 positive. We called it as 6-6 coordination. So this lattice has a whole sort of packed situation because each ion is attracted by many layers, surroundings, and positive and negative ions of the surroundings. Easy to put, cubical shape structure, the crystal grows, each positive ion attracted by 6 negative ion and vice versa. So ionic solids, crystalline solid, giant lattices. You should always name them in a single word. What? Giant ionic lattices. The word giant means never ending, grows in 3D fashion. So it means numerous huge electrostatic force of attraction is responsible for a lattice. Okay, strong packing, high energy needed to break this lattice. So properties, they should be solid then, they can't be liquid, they can't be gases at room temperature. RTP, high melting, high boiling, obvious because 3D lattices, giant lattices, locked in a crystalline fashion, high electrostatic forces operating. You need to melt, you need to separate that out. Should not have any smell and odor like a covalent compounds vaporizing off, because they are locked in a lattice, they are not free, they are not evaporating, there is no surface escape. That is the reason you use them in variety of ways in ceramics and you have no smell of that particular material, like plastic may have sometimes, other covalent compounds may have for various reasons, but ionic solid, a ceramic made up of a very good ionic compound, the glass, must not have a fragrance of its own. Conducts only, they are electrical conductor, you might have heard, but they are electrical conductor only when their ions are, when their lattices are basically slipping apart. When their ions are mobile ions, not in this form, they will not conduct electricity or heat, they will be insulator. But when their ions are free to move, so when they says, while ionic compound conduct electricity, never say this thing that they have free electrons as the by default answer. No, they have free ions. Movement of charges will conduct electricity. So that will be the right answer. They are quite resistant to heat and some of them are soluble in water, that if the water can penetrate and develop some bonds with the ionic lattice and energy may release, so water, polar solvent it is, some of the ionic compounds are soluble in it, like NaCl. And this, I said, conduct electricity when their ions are free to move. If they are soluble, their ions are free to move in water, aqueous solution, or in molten form. Remember, ionic compounds. And I said uses, some of the ionic compounds have huge uses, like the ceramics. the plenty of cutlery and other stuff we use where there is a spark going on, electrical spark, something. So there the plates of ceramics can be used. And also safe, oven safe and safe for health these ceramics are, the glasswares and other stuff made. Why? Because they have very high melting points. Magnesium oxide, aluminum oxide, check the strength of electrostatic force of attraction, the charges which are attracting there, 2 plus 2 minus, 3 plus 2 minus, huge electrostatic forces of attraction. That is the reason they are strong ionic compounds of very high melting point. Sometimes somebody can ask you to compare these with a sodium chloride, and you will say because sodium chloride no doubt a strong ionic compound, but electrostatic force is only between 1 plus and 1 minus. Here the magnitude of the charge is high, the charge densities are high, thicker they are and stronger they are in a lattice. So they are very difficult to separate. Around 4000 it takes degree Celsius to melt them. They are resistant, so they are named as refractory material, used in making fire resistant materials, fire resistant bricks, lining of furnaces. Why not furnaces are melting, not melting, temperature goes 3000 beyond, you're melting so many things, okay, pots and other stuff and all that, and kilns, lining of kilns. Reason behind is they are lined by what? The strong ionic ceramics, ionic materials, okay, and they are used in making of crucibles and other stuff. The glassware and the Pyrex stuff you use in the lab because they have strong ionic compounds. So huge uses these ionic compounds have for us, okay, making things safer, these ionic solids.